Our next lab will be experiment number 5, layout design of a NAND gate and a NOR gate. So I will be doing the NAND for you. You will be doing the NOR for me. Okay. So first of all, hello, can you hear me? Can you hear me all?
Yes, sir. Yes.
Okay. Okay. I cannot speak very fast today. I'm speaking very slowly. So pardon me for that. The objective will be manually design the mask layout of a NAND gate and a NOR gate. To check the design for design rule error, check the functionality of the design using simulator, built-in simulator. That's it. Pretty simple, pretty straightforward. And here, this is our NAND gate. We know it. This is the logic level circuit. This is the truth table. 0, 0 is 1, 0, 1 is 1, 1, 0 is 1, and 1, 0, 1, 1 is 0. This is the circuit or switch level circuit. Okay. And from here, we will go and make this circuit. Okay, I'm not sure whether it is okay or not because this was done in 2016, but there might be some mistake. In any of the lab, in any one of the lab, there is a mistake. Okay, I'm not sure which one it is. Okay, let's do it by ourselves. Okay, here you can see there are two MOSFETs, two P MOSFETs. Okay, at the top, they are in parallel, and two N MOSFET, they are in series. But interestingly, their sizing is 2, 2, 2, 2. This is 2, 2, 2, 2. Why? Because they are in series. That's why 1 is multiplied by 2. 1 is multiplied by 2. Normally, 1 should be the actual case. But since they are in both of them, that means 2 of them are in series. So 2 will be multiplied. So 2, double. Here, only one MOSFET is in this path. So 2 will be there. It will not be multiplied by anything. It is 2. Only one MOSFET is there, so it will be 2 here. So interestingly, all of them are having the same sizing, right? So A has the same size, B has the same size, 2, 2, 2, 2. So 1 was equal to 6 lambda, right? Remember, in our first lab, that was lab number 4, 1 means if there was 1 means 6 lambda, right? Right? 2 means how
12.
much?
12.
12 lambda. So since all of them are 2, 2, 2, 2, so all of them will be 12 lambda. So let's go to our circuit software. At first, you have to select the foundry. Remember, whenever you are opening the software, you have to select the foundry. Then you have to adjust the zoom or the, what should I say, the scale size. Here it is 1 lambda. So if it is not 1 lambda, you have to make it 1 lambda. So if it is 5 lambda, you have to click zoom in until you get the 1 lambda. That's it. I can zoom it a bit as well. Now here, at first we have to take the NMOS, right? NMOS will be here. This one, 12. This one is 10. This one is 10. 10, 10 is there. So I want to increase this. 10, 1, 2, 3, 4. So 14 is there. 14 length, right? That means the 14 lambda is the length. Now 12 lambda will be our what? Our width. So 1, 2, 12. 12 lambda is our width. So here you have 14, here you have 12. Now the N diffusion or contact, actually, not diffusion, contact. N diffusion and metal contact. So one for drain, one for source. That's it. Now go up. So how to go up? You can use this arrow or you can use the keyboard arrow. Okay? Keyboard arrow. Go up. So there will be a gap of 12. This is 8, 9, 10, 11, 12 gap. So here you got 6, maybe 1, 2, 3, 4, 5, yeah, 6. So you have to increase it. How to increase this? Click here, click this line. 7, 8, 9, 10, 11, 12. So this is 12 by 14. Again, P contact I will bring. Remember, use P type for P type, N type for N type. Do not mix it up. Okay. Now then you have to use the N well. Oh, N well later. We will use the N well later because because here we will have a common n well, common. Because they are parallel, we will have a common n well. So n will be later. Now I want to use the polysilicon. So as you can see here, you have 3 lambda extra, and this is 2 lambda, right? So I want to bring it up to this. So how to do that? Click this, click the bottom part, not here, bottom part. 1, 2, 3. That's it. Done. Now click all. All means it will come at the one window. Okay. Now I want to copy. This is for A because this is 2. This is also 2, and the sizing of B is also same, 2 and 2, right? So I want to copy this. So how to copy this? Click this. Copy from bottom, not from top. Copy from bottom. This is from experience, because if you copy it from top, you will have some adjustment issue. Copy from bottom. Now here you have to give a gap of 6 lambda. At least 6. 1, 2, 3, 4, 5, 6. That means at least 6 lambda you have to give a gap. Now click DRC for any error. No error is there. Okay, now you have to apply the n well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So any error? No error. Okay, now. So our structure is ready. Now you have to connect. How to connect? See, our source are connected together at the top, and our drain is connected together, right? So let's connect our source and drain. Which one is source? Let's say our left side is source. Okay, left side is source. Okay, left side is source. So this should be connected. This one should be connected. This one should be connected. Remember, the metal distance must be 4 lambda. Distance. You cannot come this close. You have to come through these. Okay. You cannot go through here because it will be too close. If the metals are too close, there will be a problem. What type of problem? The layer will be so close that time it can actually spark. It can actually create some spark. Accident can happen. Okay. So your IC can be blast. Okay, there will be fire. Now the metal one, I will select metal one. These up to this. Let's check any error. No error. So this will come down. We have to make it come down. Okay, that's it. Now remember, go to there. Our source connected. There you have to put your VDD. Okay, there you have to put your VDD. So let's put the VDD there. That is here. Source connected. Here you have to put the VDD. So let's putting the VDD here. And we have to use an extra VDD, here as well. Okay. Now come to the bottom part. Remember, this is our drain. This is our source. This is drain. This is source. Okay. So upper drain is connected to the lower drain of A. Okay. Upper drain is connected to the lower drain of A. So let's use that. This is A, this is B. You can use this A, you can use these as your A, these as your B, no problem. But I want to use these as my A. So this drain and this drain should be connected. Okay. A drain আর এই drainটা connect হবে কারণ যে আমাদের এইটাতে ছবিতেই তাই বলছে যে drain and this drain will be connected. So I'm going to connect. Are you understanding, all of you?
Yes, sir.
Is there any problem?
No, sir. I'm understanding.
Next connection will be what? So this is done. Next connection will be source to B drain, right? A source, B drain. Okay, A source, B drain. Which one is A source? A source is this one. Which one is B drain? B drain is this one, right? So they should be connected. How they should be connected? Like this or like this? Which one?
Sir, from the lower part.
Yeah, from the bottom. Because if you
Yes,
go through here, these two will
it will
be
be
connected,
closer.
right?
Yes, sir.
They'll
it will
be short.
closer.
So you have to go to the bottom. Like that. Now at last you have a source of B that should be connected to the ground, right? B
Yes,
source
sir.
should be connected to the ground. There is a B source here. This is the source of the B. This should be connected to the ground. Now I can bring it down like this, and I can put the ground here. Remember, you have to give a gap of 4 lambda, right? 4. No error. So I can give the ground here, or I can give the ground here as well. So you do not have to bring it down. You give the ground there. But normally it is a good practice to bring down the metal as a pin. So this will be your ground. That's it. Now our input, this is our A input, this is our B input. I'm clicking these for my input, that means this clock. I'm placing at A. I'm calling it A. The voltage should be 5 and the time should be 0.91, 0.09, 0.01. So together they become 0.1. Now the B should be connected here. Let's call it B. Voltage is 5. Now it is double the time, 0.19 and 0.01. That means 0.2. Previously the time was 0.1. Now the time is 0.2. That means it is double. Always it becomes double. Because otherwise you cannot see your 1, 1, 0, 1, 1, 0, and 1, 1, 0, 0. Now output will be where? From where you will take your output? From the upper drain and the lower drain connection, you will take your output, right?
Yes, sir.
From the connection between your upper part and the lower part, you have to take your, from here, you have to take your output. Let's take the output from here. This is our Y. That's it, right? So is there any error? No error. So this is our design. Now let's run it. So this is the simulation. As you can see here, when our input is 0, 1, your output is 1. When your input is 1 and 1, your output is 0. When your input is 0 and 0, your output is 1. When output is 1 and 0, it is also 1. As you can see, for 0, 0, for 0, 0, it is 1, right? For 0, 1, it is what? 1. For 1, 0, it is what? 1. For 1, 1, what is this?
0.
0. Is our truth table okay?
Yes, sir.
It's okay.
It is okay, right? Okay. So now your job will be making what? Making the NOR, okay? Hello?
Sir.
The NOR, right?
Yes, sir.
Okay, what is the length? It is 14. What is the width? What is the width?
24, sir.
24. Okay, let me count. 10, 10, 20, 23, 24. Yes, 24. The bottom one?
Bottom same, sir.
Same. Okay, go to, okay, let me, you stop the share. You stop the share for a second. Let me share something for you first. Here, look at this. What is the sizing of this one? 4,
sir.
right?
Yes,
What
sir.
is this? 4. That means it is 24 lambda. It is 24 lambda, right? What is the sizing of
Yes,
this
sir.
one?
This is 6. Sorry, sir.
6, right?
Yes, sir. 6
Should be
lambda.
6, not 24. It should be 6. Okay, the 24 will still give you the result. 24 will still give you the result. No problem. Okay, I'm stopping the share. You can continue. Okay.
Sir.
Yeah.
For example, this is out of my screen or out of my
Okay.
window.
Click. Okay. Click all.
All.
Yes.
At that time, sir, my lambda will be
Yes.
5.
The lambda will be 5. Okay. No problem. In that case, what will happen? Work like this. Okay. Make it 1 lambda. Make it 1 lambda. Okay. Oh, yes. In that case, you use the arrow button to navigate. Not is the keyboard arrow.
Yes, sir.
Keyboard arrow. Navigate. Okay. Make the design. Then click all at the last. Got it?
Yes, sir.
Okay. You navigate. Then you make the design at the last. That's it. Okay. I think I can start my screen, right?
Yes, sir. Yes, I understand.
Now, quickly, I am going to go through the NOR gate quickly, very quickly. It is not necessary, but it is a good practice that you will select the CMOS 90 all the time. So at first, the upper one will be 24, right? This is 10, this is 20, 21, 22, 23, 24. It will be 14 as well.
Sir, how can you count easily?
Okay, how can I count easily? Can you
Yes,
see?
sir.
Can you see? This is a bigger dot.
Yes, sir.
Some bigger dots are there, right?
Yes, sir.
So in between dots, there are 10. 10. Got my point?
Yes.
So if I start from here, I know here it is 10. It is 20.
Yes, sir.
Got it?
It takes so much time to me.
Exactly.
Count one by one.
Exactly. Got my point? I know where it is. Where are the big dots?
Sir, can I count the downside, sir?
Yes, you can.
In here, sir, there's a 14 times 24 lambda here.
Yes. Here it is 24.
No, sir,
Here
this
is
one.
14.
Sir, here sketching box to sizing, sir. The line, the down line, sir.
Okay. Let me show you one more time. Okay. One more time. See, here I am starting from here, right?
Yes, sir.
From this big dot. So up to this it is 20 because 1
Yes, sir.
and 2, 20. So 21, 22, 23, 24. That's it. Then up to this it is what? It is 10, right?
Yes, sir. Yes, sir.
11, 12, 13,
14.
14.
Sir. Yes.
Got it?
Yes, sir. Good.
Okay. That's it.
Sir, I'm here, sir. I'm see here as well.
Where?
Is sir, clean defaults a box here, downside in the window side.
Yes, this one.
No, sir, down, sir, down. This line, sir, white line.
White line.
Yes, sir. Yes, this one, sir. Yes.
Yes.
When you click, sir, this box, then you will write. It will be writing here, sir. Yes, like this one. When you click the box, yes, sir. When you click this box, then it will be writing here.
This one.
No, not sir, not sir.
Okay, I'm going to make you the co-host. Okay.
Okay, sir.
Schweib, you are the co-host now. You can share your screen.
Sir, can you see that?
Wait a second. Oh yeah, I can see.
Okay. I see, sir, like this. For example.
Okay, click all first. Click all.
Like this, sir. Here, sir, here. When you click this one.
Oh yes.
Here, sir, you can see, sir.
Yeah, you can see. Yes, you can see. But that is for looking purpose. But when you design, you have to count those big dots. Okay. If you count those
okay,
big dots, it will be much easier to quickly draw. Got it?
okay, yes, sir, yes.
You can stop the share.
Okay, sir.
Stop the share.
Okay, sir. Stopping share.
So can you see my screen?
Yes, sir, yes.
So this is the PMOS. Now you have to make an NMOS. Remember, the minimum gap should be 12, but you can go a bit bigger if you want. So I'm going to go 16. Okay. If you want, you can go a bit bigger. Remember. Got it?
Yes, sir, we get.
So this is 24, this is 6. So I have given a gap of 16, not 12. If you want, you can make it 12 as well. This is N type. This is N type.
Sir,
Yeah.
how to calculate 24 and 16?
How to?
How to simplify, sir, 24 and 16 width and length?
Yeah, the width and length. The length is 14. I already explained why it is 14. Okay, because you have one lambda extra, then 4 gap, then again 4, then 1. So 4, 4, 4, 12, and 1, 14. So length will be 14 always. Okay, the minimum length. You can make it 16 as well, no problem. Here one extra, here one extra. You can make it 16. You can make it 20 as well. But normally we want to make our design as small as possible. So it is 14. Now, since it is 1, it is also 1. So it should be 6, minimum 6. Maximum, you can go 10, 12, doesn't matter. But when our 1 is equal to 6, how much our 4 will be? If 1 is equal to 6, how much our 4 will be?
24.
24. That's why it is 24 and this side is 6. Okay?
Yes,
Yes,
sir.
sir.
Okay. So this is P type and this is also P type. Now I want to connect the polysilicon. Let's check for any error. No error. So this is our A. So I want to copy it for B because our A is 4-1 and our B is also 4-1, right? So they are similar. That's why I can copy it. If they were not similar, then I could not copy it. Got my point?
Yes, sir, understand.
Okay. So I want to copy this from the bottom. I will copy. So there will be 6 gap. 1, 2, 3, 4. Okay, this is the 6. Because from here it was 4, then 6. So that's the next dot. Okay. So now the N well. So N well should be here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. Is there any error? No error. Okay. Now the connection time. So how the connections will be made? Remember, the A source is with the VDD. Then drain is connected to the B source. Then A drain is connected to the drain at the bottom. Okay, let's do the bottom first. Okay, let's do the bottom first. So drain and sources will be connected. Drain and sources will be connected. Which one is the other? This is the drain. So let's connect. Now you will understand why I have taken the gap as 16. Okay, do you know why? Because if I take it 12, this space will be very much smaller. Then I will not get any. I will not get any place to put my what? To put my input. Got it?
Yes, sir.
Now, the drain and source is connected. Now the source will have the VDD. As you can see, source is the VDD. So I'm connecting to the VDD here. And the drain will be connected to the B drain. B. This is the B. So this is the B. So B drain will be connected to the B drain. Okay. Now check this one here. This is the B. B source must be connected to the A drain, right? A drain, B source. So which one is our B drain? Now B source. This is our B source, right?
Yes, sir.
Which one is our A drain? This is our A drain, right?
Yes.
So they will be directly connected. Now, next, our A source will be connected to the VDD, A source. So let's take it like that and connect the VDD here. It will be 5 volt. Connect a VDD, an extra VDD here as well. It will be 5 volt. Understood, everyone? Now connect the inputs. This is our A. This will be 5 volt. And the timing is okay, 0.09 and 0.1. Here as well. This is P. It's fine. This will be our output, where our PMOS side and NMOS side are connected. That is our output. If I check the error, no error is there. So if I run the simulation, this is our simulation. Okay. So when our inputs are 0, 0, our output is 1. When it is 1, 0, it is 0. When it is 0, 1, is also 0. When it is 1, 1, it is also 0. So only 0, 0 has one output. Got my point? This is exactly like your NOR gate. Understood, everyone?
Yes, sir, I understand.
Okay. So your job today, your job will be making a what is that? The lab report that will have this NOR gate, this NAND gate, and as well as what? Free input NAND gate as report question. Remember, extra question. And free input NOR gate. Okay.
Okay, sir.
Okay. Remember, if you, I will. What is that? Did I make the submission portal for your lab reports?